Since humans first gazed up at the sparkling night sky, the universe has become a mysterious, captivating, and challenging frontier. The distant stars, enigmatic planets, and the infinite void beyond have always raised profound questions. Who are we? Where do we stand in this vast, mysterious canvas? These mysteries have ignited a fierce desire in humanity's heart to push beyond all limits and seek answers in the boundless universe. This is humanity's greatest and most challenging adventure. Despite all obstacles, we began our journey into space with small steps, leading to giant leaps. We confront our own limitations, proving our resilience, courage, and endless dreams. And to this day, that journey has never stopped. So, when did humanity ignite this daring voyage? Beyond facing challenges, what achievements have we unlocked? Let's revisit this glorious adventure in today's video. From Earth to the stars, humanity's journey into space. From the dawn of civilization, humans have explored the universe in unique ways. With rudimentary tools and no telescopes, our ancestors relied on naked eye observations of celestial bodies like the sun, moon, and stars. These observations led to the discovery of patterns day and night cycles, seasonal changes, and lunar phases. Civilizations such as Egypt, Mesopotamia, India, and China recorded astronomical phenomena, creating calendars to guide agriculture and daily life. Eclipses and other celestial events were meticulously documented, reflecting humanity's boundless curiosity. To gain those early understandings, ancient people had to spend many generations observing the sky and recording the changes of celestial bodies. The most remarkable achievements came from the ancient Babylonian astronomers. As early as 4,000 years ago, they had acquired extensive knowledge of the universe and were even able to predict natural phenomena. Additionally, ancient people used simple tools such as altitude measuring sticks or wooden circles to determine the positions of celestial objects in the sky. They could identify constellations, which led them to create myths and stories related to the stars they observed. The identification and classification of constellations not only helped them with navigation, but also played a crucial role in weather forecasting and agricultural planning. Most notably, the astronomical knowledge that ancient people gathered through naked eye observations became the foundation for the development of a scientific system. This was the cosmological model of ancient Greek civilization. It was synthesized, formed, and developed by philosophers and astronomers. At the same time, it laid the groundwork for humanity's future understanding of the universe. In the 4th century BCE, ancient scholars developed the idea that the stars were fixed in the sky and revolved in a spherical orbit every 24 hours. Meanwhile, planets such as the Sun and the Moon moved in the space between the Earth and the stars. This model was further refined in the following centuries, reaching its peak in the 2nd century CE. He believed that perfect motion had to occur along a circular orbit. Therefore, both stars and planets moved in circular orbits. However, to explain the complex, cyclical movements of the planets, Ptolemy proposed that each planet moved along a fixed circular path around a stationary Earth. This was the geocentric theory, originating from Aristotle in the 4th century BCE, which asserted that Earth was at the center and remained motionless. Additionally, some Greek philosophers proposed heliocentric models, in which the Sun was considered the center of the universe. Among them was Aristarchus of Samos, one of the first to suggest such a model, marking a major divergence in astronomical science at the time. However, this perspective was not widely accepted in antiquity. This was because, when observed with the naked eye, the sun, moon, and stars all appeared to revolve around the Earth. It must be said that the cosmological model of ancient Greece reflected humanity's evolving thought about the universe and our place within it. Despite its limitations, their theories and discoveries laid the foundation for future advancements in astronomy and science. The fusion of observation, knowledge, and belief created a valuable legacy, allowing humanity to continue exploring and understanding the vast universe. Not only that, but based on astronomical knowledge, humanity has been developing calendars since ancient times. They realized that the cycles of the sun, moon, and stars were repetitive, leading to the division of time into units such as days, months, and years. A day was determined by Earth's rotation on its axis, from sunrise to sunset. A month was typically based on the lunar cycle, specifically the time between two full moons, which is about 29.5 days. A year was defined by the time it took for Earth to complete one orbit around the Sun, approximately 365 days. Different civilizations developed their own calendars and timekeeping methods, but among the most famous were the Mayan and Babylonian calendars. First of all, the ancient Mayan calendar was one of the most complex and accurate calendar systems in history, developed by the ancient Maya civilization in Central America. It consisted of three main types: the Harb calendar, the Tzolk'in calendar, and the long count calendar. Each of these had its own purpose and method of calculation, yet they were interconnected within the Maya timekeeping system. Rather than functioning independently, these calendars were interwoven in a complex cycle. Every 52 Harb years, or 73 Tzolk'in cycles, both the Harb and Tzolk'in calendars would conclude a full cycle and start over from the beginning. This period, known as the calendar round, was an essential and sacred time cycle in Mayan life. In addition, the Babylonians created a lunar calendar based on the cycles of the moon, with each month calculated from one new moon to the next, approximately 29.5 days. The Babylonian lunar year consisted of 12 months, totaling about 354 days, which is shorter than the solar year, 365 days. This discrepancy caused a difference of about 11 days per year between the lunar calendar and the solar cycle. To adjust for this gap and align their calendar with the seasons, the Babylonians added a leap month. As pioneering astronomers, the ancient Babylonians observed astronomical cycles and discovered many fascinating phenomena, including the planet Venus. This discovery not only helped them create an accurate calendar, but also laid the groundwork for many astronomical and calendrical systems in other civilizations. The astronomical knowledge and achievements of ancient civilizations were passed down and used for a long time due to their accuracy in daily life. During the Renaissance, many researchers of the universe began to question the true nature of the planets. When observing with the naked eye, one could only distinguish the sun and the moon. The rest of the stars appeared to be just tiny points of light in the sky. To gain a deeper understanding of the universe, humanity needed a special tool to observe the planets. That tool was the telescope. In 1608, a Dutch lensmaker named Hans Lippershey was the first to patent a device that could magnify distant objects. It was remarkably compact, handheld, and featured a convex lens at the front and a concave lens at the back. Thanks to this design, users could magnify the image of distant objects, making it easier to observe them. However, due to its simple construction, the image viewed through Lippershey's telescope appeared upside down. Additionally, the magnification was only 3x to 4x, which was not powerful enough to observe planets and stars clearly. Moreover, the image quality was not sharp, so fine details of celestial bodies could not be seen. Nevertheless, it marked an important step forward in the development of remote observation devices, and it served as inspiration for scientists to improve telescopes for further exploration of the universe. During this period, everything changed. A major shift in the journey of exploring the vast universe occurred. The concept of the Ptolemaic geocentric system was no longer accurate. European astronomers began to have alternative views about the universe and the planets. One of these figures was Nicolaus Copernicus, one of the most important figures of the Renaissance. His research not only fundamentally changed humanity's understanding of the universe, but also laid the groundwork for the scientific revolution, setting the stage for the development of modern sciences. This was the heliocentric theory, where the Sun, not the Earth, was at the center of the universe. In ancient times, this theory had been proposed before, but did not gain widespread support. However, after years of research, Copernicus embraced the idea that the Sun was the center of the universe, while the Earth and other planets orbited around it in circular paths. He also introduced additional concepts that were far more accurate and simplified compared to previous models. According to him, the Sun was fixed and did not revolve around any other celestial body. The phenomenon of day and night was caused by Earth's rotation on its axis, rather than the motion of the entire universe around Earth. The planets in the solar system orbited the Sun along their own unique paths. Planets were positioned at different distances from the Sun, which accounted for the variations in their apparent speeds in the sky. Before Copernicus, calculating the positions of planets was extremely complex, requiring intricate mathematical models to explain their movements. Through the heliocentric model, Copernicus successfully simplified this labor-intensive task. His work became the foundation for future scientists, enabling a more precise description of the universe. Copernicus's research transcended astronomy, sparking a profound intellectual revolution. His heliocentric model challenged the long-held belief that Earth and, by extension, humanity occupied a central and privileged position in the universe. This paradigm shift encouraged people to reassess their place in the cosmos, influencing philosophy and theology, and directly confronting the traditional doctrines of the Catholic Church. Furthermore, his work contributed to the rise of rationalism and modern science. Many scholars built upon Copernicus's groundbreaking achievements, bringing humanity closer to an understanding of the vast cosmos. They shattered outdated worldviews, introduced revolutionary research, and advanced human knowledge despite facing fierce controversy. And yet, the Earth still moves. You have probably heard this phrase at least once or know about it. It was the astronomer Galileo Galilei who made this assertion. He was one of the most significant figures in the history of astronomy and physics. Galilei was the first to apply the experimental method to scientific research, laying the foundation for modern physics and astronomy. To explore planets and stars, he built an upgraded version of the telescope based on the design of Hans Lippershey. Galilei's device could magnify objects up to 20 times, allowing him to make many important astronomical observations. Most notably, he discovered 4 large moons orbiting Jupiter: Io, Europa, Ganymede, and Callisto. He also found that the moon's surface was not smooth, but full of mountains and craters, contradicting the belief that celestial bodies were perfect and unblemished. Additionally, he observed sunspots, proving that even the Sun undergoes changes. One of his most remarkable discoveries was the phases of Venus, which marked a major breakthrough for humanity. At that time, the Catholic Church and European society still strongly adhered to the geocentric model proposed by Ptolemy. However, Copernicus had questioned its accuracy and introduced the heliocentric theory, sparking intense debate. Galilei's discovery of Venus's phases became one of the most famous stories in the history of space exploration. In 1610, Galilei published The Starry Messenger, documenting his astronomical findings. The book caused a sensation, attracting the attention of both the scientific community and the Church. He provided strong evidence supporting the Copernican theory, which was seen as provocative and defiant by the Church. In 1616, the Church warned Galilei not to teach or defend the heliocentric theory. Despite this, he continued his research and even engaged in public debates with scientists and clergy who supported the geocentric model. By 1632, Galilei published Dialogue Concerning the Two Chief World Systems, in which he compared Copernicus's heliocentric model with Ptolemy's geocentric model. Although the book had a neutral tone, it clearly favored the heliocentric theory. The publication sparked a wave of controversy, infuriating the Church. In 1633, Galilei was summoned to the Roman Inquisition, where he faced charges of heresy. Under immense pressure from the Inquisition, he signed a confession declaring that Copernican theory was false and inconsistent with Catholic doctrine. At that very moment, he is said to have whispered, "And yet, the Earth still moves." This statement affirmed his unwavering belief in scientific truth that the Earth continues to orbit the Sun, regardless of whether the Church accepted it or not. Galilei's work later inspired scientists like Johannes Kepler and Isaac Newton, who continued to develop scientific theories about the universe. Galilei's contributions extended beyond astronomy, paving the way for the advancement of modern science and helping humanity gain a better understanding of its place in the vast cosmos. By the 17th and 18th centuries, tools for studying stars and planets had improved significantly. Many brilliant scientists developed their own advanced telescopes. One of the most notable figures was this man, Isaac Newton. Newton was not only famous for the apple falling story that led to his discovery of gravity, but also for his invention of the reflecting telescope. By 1668, Newton noticed that telescopes of the time produced blurry and inaccurate images. He sought to enhance their performance by improving the lens system. Instead of traditional lenses, Newton used a parabolic mirror as the primary reflective surface. He designed a telescope with a concave mirror that collected light, focusing it at a single point inside the tube. A flat mirror, placed at a 45-degree angle near the focus, reflected the light to the side, where an observer could view it through an eyepiece. The eyepiece magnified the image, making celestial objects much clearer. Newton's reflecting telescope provided sharper, distortion-free images, allowing scientists to study planets more accurately. Additionally, it was cheaper to manufacture, as mirrors were easier to produce and did not require the same purity as large lenses. Newton's invention marked the beginning of the reflecting telescope era, which became the standard in modern astronomy. Thanks to his advancements, astronomy entered a new chapter. Alongside the development of telescopes, by the late 19th century, scientists had begun to study the lifespan and evolution of stars. This was considered a major breakthrough, adding new pieces to the vast cosmic puzzle. Two scientists, Hermann von Helmholtz and Lord Kelvin, played a crucial role in this discovery. They found that stars form within massive clouds of gas and dust, known as nebulae. Under the influence of gravity, regions within these gas clouds begin to contract, gradually forming a dense gas mass. This process generates extreme heat and pressure at the center, leading to the birth of a star. When the temperature and pressure at the core become high enough, nuclear fusion begins. Hydrogen atoms fuse into helium, releasing energy in the form of light and heat, causing the star to ignite and officially become a main sequence star. At the same time, humanity was also learning more about the Milky Way, home of Earth, and hundreds of billions of other stars. The great astronomer William Herschel was the first to conduct detailed observations of this massive spiral galaxy. Using his giant telescope, he mapped the distribution of stars in the Milky Way, recognizing its shape. Herschel also discovered that the Milky Way is not a dense cluster of stars, but rather a vast collection of scattered stars. By the late 19th and early 20th centuries, astronomers realized that the Milky Way was only one of millions of galaxies in the universe. These discoveries were made possible by advancements in telescopes and spectroscopy, which allowed scientists to classify galaxies and gain deeper insights into their formation and structure. During this period, Edwin Hubble made a groundbreaking discovery: the Milky Way was not the entire universe. By observing nebulae, he proved that these were actually separate galaxies beyond our own. His discoveries transformed our understanding of space, revealing the vastness of the universe and our small place within it. Shortly after, in the 20th century, humanity took giant leaps forward, beginning its journey to conquer space. One of the most important discoveries of the 20th century was Albert Einstein's general theory of relativity, published in 1915. This theory revolutionized humanity's understanding of space and time. Instead of treating space and time as separate entities, Einstein described them as a single unified fabric called spacetime. With general relativity, Einstein proposed a cosmological model in which the universe was not static but could expand or contract. This idea opened new questions and research into the formation and structure of the universe. In 1920, the astronomer Edwin Hubble discovered that galaxies were moving away from each other. This provided clear evidence that the universe was expanding. Scientists later developed this finding into the Big Bang modeler theory, stating that the universe originated from an extremely hot and dense point, approximately 13.8 billion years ago. Following a massive explosion, the universe was born and has been expanding ever since. However, humanity's understanding of space did not stop there. During this time, knowledge of the vast cosmos continued to expand, and a series of groundbreaking achievements marked humanity's journey into space. At 22 hours 28 minutes and 34 seconds on the 4th of October, 1957, the R-7 rocket was launched from Baikonur Cosmodrome in Kazakhstan, carrying Sputnik 1, a small aluminum sphere, into space. This was the first human-made satellite to orbit the Earth. 314.5 seconds after separating from the rocket, Sputnik began transmitting its famous beep-beep signals, which were detected by tracking stations on Earth. The satellite successfully entered orbit at an altitude of 947 kilometers, carrying with it humanity's ambition to conquer space. Sputnik 1 orbited the Earth 1,440 times. Just 4 years after Sputnik 1 entered space, the Vostok spacecraft, carrying cosmonaut Yuri Gagarin, launched from the Baikonur Cosmodrome in Kazakhstan. At that moment, Gagarin became the first human to witness our shared home from space. After orbiting Earth for 108 minutes, Gagarin safely parachuted back to the ground in a field in the Saratov region. This historic spaceflight was a major success, marking the first time a human entered space. It became a symbol of Soviet pride and one of the greatest achievements of the Cold War era. However, the Soviet Union's space rival, the United States, was determined not to fall behind. The United States, the Soviet Union's rival in space exploration, refused to fall behind in the race for the stars. In response, the Americans planned an even bolder, more challenging mission to become the first nation to conquer the Moon. On the 16th of July 1969, the Saturn V rocket launched the Apollo 11 spacecraft, carrying 3 American astronauts, Neil Armstrong, Michael Collins, and Buzz Aldrin, into space. After more than 3 days in orbit, on the 20th of July 1969, Apollo 11 became the first manned spacecraft to reach the Moon. Neil Armstrong became the first human to set foot on the Moon's surface, declaring the iconic words, "That's one small step for a man, but one giant leap for mankind. This great achievement did not mark the end of humanity's quest to conquer space. On the 20th of August, year 1975, NASA officially launched the Viking program. Two spacecraft, Viking 1 and Viking 2, were tasked with landing on Mars, the Red Planet. This was one of NASA's most expensive yet highly successful missions. Throughout their operational lifetimes, the Viking landers collected valuable data about Mars, significantly contributing to the study of the planet, which is considered the most Earth-like world in our solar system. Notably, the data revealed evidence of massive ancient rivers stretching for thousands of kilometers. To support the study and exploration of the universe, astronomical instruments have been continuously upgraded and improved. This advancement is considered one of the greatest leaps in the 20th century. Launched in 1990, the Hubble Space Telescope revolutionized how we observe the cosmos. By eliminating atmospheric distortions, Hubble has provided crystal clear, high-resolution images of galaxies, stars, planets, and various celestial phenomena. The Space Telescope has helped confirm numerous cosmological theories and provided strong evidence for the expansion of the universe. Additionally, the development of radio telescopes ushered in a new era of astronomy, allowing humans to gain deeper insights into supernova explosions. Many experts have realized that human understanding of space is still extremely limited. Nations must cooperate to expand their knowledge and lay the groundwork for long-term space missions in the future. As a result, the International Space Station, ISS, was born. This orbiting laboratory serves as a shared home for astronauts and space scientists from various countries, including Russia, the United States, Japan, and Canada. Together, they conduct research in multiple fields, such as the effects of microgravity, space exploration technologies, and life sciences. In short, this project is not only a technological marvel and a symbol of international collaboration, but it also represents a major step forward, laying the foundation for humanity's future space endeavors. With the support of spacecraft and satellites, humans quickly gained knowledge and explored the planets within the solar system. This marked the beginning of the journey to explore the outer edges of the solar system. On the 19th of January, 2006, the New Horizons spacecraft was launched into space with the mission of exploring Pluto. It was launched at an extremely high initial velocity and later used Jupiter's gravitational pull to accelerate a technique known as gravitational assist. In 2007, New Horizons approached Jupiter, collected valuable data on the planet and its moons, and used the encounter to accelerate toward Pluto. The spacecraft took the opportunity to capture images and conduct scientific observations of Jupiter and its moons. On the 14th of July 2015, New Horizons reached its closest approach to Pluto, at a distance of about 12,500 kilometers. This was the first time humanity had a close-up look at this dwarf planet. After completing its Pluto exploration mission, NASA expanded New Horizons' mission to study the Kuiper Belt, a region beyond the solar system filled with icy objects and the birthplace of comets. In 2019, the spacecraft approached 2014 MU-69, also known as Arrokoth, setting a record as the most distant object ever explored by a spacecraft. To this day, humanity has made tremendous progress in exploring and studying outer space. Countless missions have been launched, and many successes have been achieved. However, space exploration is now entering a new era of rapid development, filled with ambitious plans. From setting foot on Mars to observing exoplanets beyond the solar system, we are getting closer to a deeper understanding of the universe and our place within it. These plans may have once seemed vague and nearly impossible, but you and I have witnessed them gradually becoming reality. Without a doubt, the coming decades promise to be a golden age of space exploration, with bold missions, advanced technology, and groundbreaking discoveries that could completely reshape our understanding of the cosmos. From the early observations of the sky and the stars, humanity has gradually conquered the vastness of space. The achievements we have made are the clearest evidence of the intellect and the limitless curiosity of humankind. Each historical stage, whether with or without supporting tools, has contributed valuable insights to the vast cosmic picture. Today, with planetary exploration missions and space telescopes, we are closer than ever to uncovering the origins of the universe and the possibility of life beyond Earth. This journey will undoubtedly face many challenges, but it will not stop humanity from continuing to explore. Now, or in the future, humankind's conquest of space will not cease, for there are still many mysteries we have yet to discover.